Students, Unit 7 test review. We are going to find volumes, surface areas, all the stuff for it, or revolve stuff. It's going to be a blast. You will be given the formula that we are going to list up here, and the formula should be easy to understand / remember. We got the same for the cylinder and the prism, essentially. The same for the cone and the pyramid, essentially. It's where the surface areas differ a little bit. Where is my cursor here?
Featured in the mouth.
We might be able to hear your voice. I just started it. What happens when you just video bombed
I'm sorry.
my homework? You just video bombed me. Is that what it's called? A photo bomb or something? Yep. Great. Notice the cylinders and the prisms. Area of the base times the height. Area of the base times the height. A third of the area base times the height. A third of the area base times the height. Cool. Spheres, different, but we get into how the sphere and the cone and the prism all work together. No, I think that would be great. I think handle it now. You'd be great. Uh, surface area of the cylinder. I honestly don't want to give you the formula for this. You should know it. I'll give you the surface area of the cone. It's pi r squared plus a pi r l. The pi r l part is the part in the middle. Surface area of the sphere is 4 pi r squared. You don't know the surface area of the cylinder, we got problems. Guys, this triangular prism, which is a 3, 4, 5, right triangular prism. How do I know that it's 3, 4, 5? I use the Pythagorean theorem to find it. 3 squared plus b squared equals 5 squared. It's got a height of 6. Now, how do I know it's a triangular prism? There's two triangles, a bottom and a top. It's like, well, that's not the bottom and the top. That's like on the sides. It's like, yes, a prism can be oriented in different ways, but it's the shapes that are just repeated twice, the bottom and the top. Those are the shapes that we care about the base. I had just such discussions with one of my classes. The shapes that are repeated twice are the base. Okay. So we have the volume, which is the area of the base, times the height. The area of the base is the area of this triangle. The area of this triangle is 6. So I have the area of the base times the height. My volume's 36. What about the surface area? Well, now we have to split up and take all of our shapes. I have 2 of the triangles. And then I have 1, 2, 3 rectangles. A rectangle on the bottom, which is a 4 by 6. A rectangle on this top, which is a 5 by 6. And a rectangle on the side, which is a 3 by 6. So I got a 4 by 6. I got a 5 by 6. I got a 3 by 6. So honestly, what do I have is a bunch of 6s. You just add all these up, however you get this. I'm going to do it differently. 14 6s. I have 14 6s, whatever that is. Let's break out the calculator. Two times 6 plus 4 times 6. We're going to need this calculator anyways. $84. Great. Next, A is this length here. This length is half of like this square's length. So A being 4 means this is 8. H being 6. Cool. Now we need to find this length. Now this length is that kind of diagonal length on one of my sides, which will help us find the surface area. So we might as well find that length using the Pythagorean theorem. 36 plus 16. A squared plus B squared equals C squared. 3, 4, 5, 52. So this is root 52. I'm not going to simplify it, but we could. 52 divided by 4. So this is root 4, root 13, just 2 root 13. Okay, volume, easy. 1/3 area of the base times the height. What's the area of base? 64. What's the height? 6. Great. Does it work out nicely? Oh, cool, 128. What is the surface area? Well, my surfaces are actually 4 of these triangles. Now, these triangles, like I showed you, have this length of 8. Maybe it's easier to see it over here. This diagonal length on this triangle is 2 root 13. So I have half of my base times the height, which I get 8 root 13. So my surface area is going to be 4 of these 8 root 13s. And then I have the area of the bottom, which is a 64. Okay, make sure you understand that. You don't have to have it in this order. You can have a different order, and you're good. Volume, area of the base times the height. It's a cylinder. It's not a cone. The area of the base is pi times 11 squared. The height is 16. So 121 times 16, whatever that happens to be. Pi's. Wow. 1936 pi. What's the surface area? Well, I didn't give you the formula because I kind of want my students to know. We got 2 circles, the top and the bottom, so that's 2 pi 11 squareds. And then we have the rectangle in the middle. The rectangle in the middle gets rolled out to be 2 pi r, so that's 22 pi. So it's like, imagine the thing getting rolled out. It's a rectangle. It's the circumference of the circle. So 2 pi r times the height, which is 16. So again, this is 11, this is 16. So that's 22 times 16 pi. And we'll add those together. So I got 121 times 2 for my circles. I got 22 and 16. And then I have 352 and 242. 594 pi. Great. Next. All right. Again, this is a prism. The volume will be the area of the base times the height. Well, we got to understand what's the base. The base is not a rectangle, guys. The base is hexagons. 2 hexagons, okay? Connected by rectangles. So we got to find the area of this hexagon. Oh, hexagons are the bestagons. Why are hexagons the bestagons? Because you take the 360 degrees, you divide it by 6, and you get that it's a bunch of equilateral triangles. This is 60 degrees. You don't have to divide it 360 by anything else. So since this is 60 degrees, this has to be 60, and this has to be 60. When we split this up, we get that it's a 30, 60, 90 triangle. 2 30, 60, 90 triangles when you split up an equilateral triangle. Ugh. See that again. Okay, this is 60 degrees down here. This is 30. So we're ready for a 1, 2, root 3. But since it's 4, whoa, I can't believe I just did this. We're ready for a 1, root 3, 2. small, medium, large. Since it's 4, multiply everything by 4. Makes sense that that's 8. This is 8. This is 8. This is 4 root 3. All right, so the area of a base are 6 of these triangles, half the base times height. 4 is half of the base length of 6, of 8, whatever you want to do. So that's the area of the base times the height. So I need to do 6 times 16 times 15. And I get 1440 root 3. All right, so the surface area, again, I have 2 of those 6 times 16 root 3s. Which is 96 root 3s. Plus 6 of these 15 by 8s rectangles. Okay. Half a base times height, 603. I have 6 of those is the area of the base. 96 root 3 is the area of the base. And then I have 6, 15 by 8s. So 720. And then 2 times 96 is 182. 192. It looks like I give you a slant height. Great. And I give you a radius. Great. I'm gonna use the Pythagorean theorem to get this height of this cone. So a squared plus b squared equals c squared. Six is a leg. The height is a leg. The diagonal is the hypotenuse. 2 root 34 squared. Well, it's like 2 root 34 times 2 root 34. You can multiply the 2's together. You can multiply the root 34's together. You'll find that root 34 times root 34 is just 34. This is 4 times 34. I wonder if this ends up being nice. 136. Aha, it is. Now, how did I get that? You could have also done, if you have a calculator, 2 square root 34 square, just to maybe double check until you like gain confidence in something like this. So whatever. I subtract 36, I get b squared is 100, I get b is 10. All right, great. But that's the height. The height is 10. So the volume is going to be half of a 4/3 pi r cubed plus my cone's volume, not going to have to subtract anything, which is 1/3 of a pi 6 squared times h. Let's do that. Again, I'm just adding my hemisphere, which is half of the sphere, and then the cone, 1/3 area of the base times the height. So this is 4/3 pi r cubed over 2, and this is 1/3 of the area of the base times the height. Same for a pyramid. So I got 6 cubed divided by 3 times 4. That's the 4/3, or times 4 divided by 3, doesn't matter, divided by 2. And this is 144 pi. Who would have thought? And then I got 6 squared times 10 divided by 3. 120. So that's 264 pi. Okay, so for the surface area, let's go ahead and do that. I got the hemisphere. That's the volume. That's the volume. The surface area is 4 pi r squared. And the surface area of this is just the pi RL part. So I have 4 pi times 6 squared. And then I have the pi times the r times the L. Again, how do I know the pi RL part? Remember, if you have this net, which is the unrolled top part of the cone, this is L. This ends up being the circumference of the circle on the bottom. We have the entire area of this circle is pi L squared. Then we have the 2 pi R part of the 2 pi L entire arc length, 2 pi L entire circle circumference. The 2 pi's cancel, the L's cancel. We got pi L R. I like pi L R versus pi R L, honestly. So, anyways, 36 times 4. Bring your calculator to the test. 144 pi. √34 pi. I mean, I think what we wanted you to do here, this is the design of the problem. If you do this differently, it's fine. The volume of this, which is pi r squared h, is 8 pi. So it's 4 pi times 2 is 8 pi. Now, this is like the small guy. The large guy has a volume of 144 pi. What is that difference? Not difference, but how many times bigger is that? 18 times bigger. Shoot, never mind. We're talking about the area. Area of the base is 4 pi. The area of the larger one is 144 pi. The area is times 36. Cool. Well, that means the volume, that means the lengths, which are always units, areas, units squared, volumes, units cubed. The area being times 36 means it's 6 squared. The volume, therefore, is going to be 6 cubed times the volume of the smaller one. The volume of this smaller one is 8 pi. I will multiply by 6 cubed. Six cubed is a big number, but I will multiply the volume of 8 pi by 216, and I will get the answer. Now, 46656 pi. Is everything okay?
Yeah. I just didn't do other work.
You can do this problem a different way. The different way to do this problem is to find the volume, well, to find the radius of the larger circle. But then it's like, what's the point? Pi r squared equals 144 pi. R equals 12. Cool. 2 to 12 is times 6. There you go. So that means the radius will be times 6. The height will be times 6. The radius and the height are going to be 12. You could find that pi r squared, where it's 12 squared, times the height, pi. That's yeah, it makes sense that the lengths of this. Did I not type in 8 times 2 6? Oh. 8 times 216. Yeah, there it is. 1728. I don't know what about this thing. Okay, so there's lots of different ways to get it. Whether you are figuring out the radius divided by pi square root, then realizing, oh, my lengths are going to be times 6. Boom, you could calculate the volume off of this, et cetera, et cetera. Good question. Y equals 2x from 0 to 2. 2x goes to 4. So you could also do xy. If x is 0, y is 0. If x is 2, y is 4. Got the point 2, 4. I got this line. Shade this interval bounded by the x-axis. Here is it bounded by said x-axis. Rotate this about the x-axis. We create a cone. The circle on its side. We have 1/3 base. This length is 4. This length is 2. 1/3 16 pi times 2. Leave it like that. What would happen if I revolve this around the y-axis? Well, it gets harder because spin this around the y-axis, twist the y-axis. This gets reflected over here, creates a cylinder with a cone cut out of the inside. So the cylinder is pi r squared. Did you answer your phone on the sly? Times h, 1, 2, 3, 4. So that's 4, that's 2. Minus 1/3 of a pi r squared h. You end up with 2/3 pi r squared h. Two-thirds of the pi r squared h. 16 times 3 over 3. You need a common denominator, you subtract, you get, oh wow, the same volume. Cool. This kind of showed you how we introduce spheres, but it's important to be able to write equations of these shapes in terms of just r instead of using numbers. So, for example, this cylinder starts as pi r squared, which is the area of the base times the height. I would then simplify that to be 2 pi r cubed. We know that this is 4/3 pi r cubed. And we know that this is a 1/3 pi r squared times r. But I have two of them giving me 2/3 pi r cubed. Look how this equals sphere plus double cone gives us 4/3 plus 2/3 is 6/3, which is 2. Cool. If I take something with a radius of 3, 1, 2, 3, 1, 2, 3, here you go. 1, 2, 3. Here is a half circle. You can take a full circle, honestly. Doesn't matter. But the idea is like understand that a half circle spun creates a sphere. If I spin it around the x-axis, sphere. If the radius is 3, then the volume is 4/3 pi 3 cubed. That's 27 divided by 3, 9. 9 times 4 is 36 pi. And the surface area is going to be 4 pi r squared. So that's 9 times 4, which is also 36 pi. Beautiful number. 3 with spheres. Great question. Here we go. Great question. Remember, if the lengths are times this, the areas are going to be times this squared, and the volumes are going to be times this cubed. We started with a volume of 216, and then it's scaled up so the volume of 13,824. We start with 13,824, and I'm going to divide it by 216, and boom, I get that this volume is 64 times bigger. Well, there's some number cubed that equals 64. You could figure out this number by taking the cubed root of 64, or you could just start guessing and checking. Here's the cubed root of 64, or you could figure that 4 cubed is 64. All right, so that means our special number is 4. 4, 4. That means your areas are going to be times 16. Your volumes times 64, your lengths times 4. The smaller object surface area was 72. The larger object's surface area is going to be 72 times 16. One five units squared. Oh, cool. So when we spin this, it creates a cone. And what we're missing is the cone's radius. We have the cone's height. So 1/3 pi r squared. I don't know what r is. H, which is 3. Oh, look at that. Equals 363 pi. Well, the 1/3 and the 3 will go away. There's other ways to handle the 1/3 and 3. You're fine. I'm going to divide by the pi, and I'm going to get r squared equals 363. That means r is going to be the square root of 363. Let's see. That squared times height divided by 3. Well, if this is 9, this is 4. And if I connect them, I realize this is 4 and this is 4. This is 4. So this is 12 and this is 12. It's interesting. You got to see how the net kind of folds itself up. This flap folds up. This flap folds up. The back flap folds up to meet the side flap. So that's why I know that that has to be 4. I'm going to change this question. I'm going to do this question normally, but then I'm going to change the question. I know that a right circular cylinder is just a regular cylinder. And I know that the volume is pi r squared h, and my volume has to equal 100 pi. Well, I want to solve for h. Well, I'm going to divide by pi r squared, and I get h equals 100 pi divided by pi r squared. The pi's cancel, and I just get h equals 100 over r squared. What we did here is great. It's great. But like your question on your test will be a little bit different. I'll show you this. Using this expression, right, the surface area. Well, I have 2 of my pi r squareds. Then I have 2 pi r times h. Well, I'm going to just write it like that. Now, this is great and all, but most likely, here's what's going to look like. If the radius is 2, what is the height? You know, like I'll give you one extra piece of information. You have to solve for the other. So if the radius was 2, I would turn this into 4. I would divide by 4 and 4 pi, and I'd get like the height was 25. And that would allow me to find the surface area based on that. Or I might give you that the height was 4. And if the height's 4, then you want to find the radius. You'd say pi r squared h equals 100 pi. I divide by the 4 and the pi. I get r squared equals 25. Oh, r is 5. So just like different questions like that, you'd probably see. All right, we kind of did this earlier. Like this is question number 1. Only you're sketching it. We got a right isosceles we'll call this isosceles. These are both 8 and 8. This is a 45, 45, 90, so this has to be 8 times root 2. Surface area. Height of the prism is 12. So the surface area is going to be 2 of these triangles, which is 32. And ends up being 1 8 by 8 rectangle. And then I have 2 8 by 12 rectangles, and then I have 1 8 root 12 by 12 triangles. Not root 12, root 2. All right, we're going to do some calculations. Six plus 8 times 12. 96 root 2. All right, well, 4/3 pi r cubed will equal this 24,000 pi. Pi's will go away, great. I need to get rid of the 4/3. I'm going to multiply both sides by 3/4, and then I'm going to solve for r by cube rooting. I got 24,000 times 3 divided by 4, or divided by 4 times 3. I get 18,000. I'm going to cube root both sides. How do we cube root? We take both sides to the 1/3 power. $18,000 to the 1/3 power. All right, 26.207. And then the diameter would be twice the radius, which is 0.414. Just going to make sure this is correct. If I take this and cube it, obviously I'm going to get 18,000 times 4/3. I should get 24,000 pi. Yep, times pi. All right, last question. Number 16 is a great question. We got a scoop of ice cream. It's a hemisphere, so this is a half a sphere. We got some diagrams here, some lengths. The question is, if the ice cream melts and no liquid is lost, will the melted ice cream fit in the cone? Well, we just have to compare the two volumes. What is the volume of the hemisphere, half sphere? Well, that's going to be 4/3 pi times r is 4.15 cubed. And then we're going to look at the volume of the cone, which will be 1/3 area of the base times the height. We're going to compare these two values, and if the volume of the ice cream is more than the volume of the cone, we're going to spill out. We won't be able to fit. If the volume of the ice cream is less than, I forgot to divide by 2. If the volume of the ice cream is less than, then it's going to fit. So we just have to do a little bit of calculations. Let's just do it without pi. And we do 4/3 times 4.15. You knew this separately. Cubed divided by 2 is 47.648 pi. And then 1/3 pi r squared times h. 58.556 pi. The cone's bigger, therefore the ice cream will fit. All right, we can do this. Also study your big quiz. Practice. Okay. Peace. See you Friday.